When it comes to configuring Pi interfaces, there are a common set of parameters. First, point source. This is a string of letters and/or numbers that identifies the Pi interface. It also combines with the interface ID to associate with the Pi points that it's responsible for updating. Our Pi interfaces, for example, have a point source of OPC, which gives an indication as to what type of Pi interface they are. Next, interface ID. This field allows for similar but independent Pi interfaces to share the same point source. For example, if there are 5 instances of the Pi interface for OPC-DA, they can all use the same point source label of OPC, but have unique interface IDs to differentiate themselves. This makes it possible to uniquely identify each instance and connect different sets of Pi points to individual instances. Next, scan classes. This is the frequency that Pi interface instances scan for new values. They're specified in a time format. So, for example, 00:00:01 indicates to scan every 10 seconds, while 00:01:00 means to scan every minute. For the Pi interface for OPC-DA, there is a separate set of parameters, such as the machine name hosting the OPC server, as well as the name of the OPC server itself. During our configuration of the Pi interface on PiInt2, we'll want to match settings with the instance on PiInt1. This is because in order to correctly establish interface failover, you must ensure that the settings are identical on both instances. This way, there is no functional difference whether one or the other is actively updating Pi points. Let's jump onto PiInt1 first and copy down some interface parameters which will come in handy when setting up the new interface on PiInt2. Here on PiInt1, open up PiICU. And to select a instance, click the drop-down arrow and we see our one Pi interface instance. In this general section, make sure to take note of the point source, which for us is OPC, and then the interface ID, as well as the 4 scan frequencies here. Next, let's move over to OPC-int and make sure to jot down the OPC server node name as well as the OPC server name. The OPC server is actually on this machine, PiInt1, since specified as localhost here. Lastly, let's go over to service. When the Pi interface configuration is complete, it runs as a Windows service, meaning it can run under a username as well as have dependencies on other Windows services. Here, take note of the service's display name, username, as well as these 2 dependencies. Alright, looks good. Let's jump back to PiInt2 and begin configuring a Pi interface instance. Let's start by launching PiICU. So I'm going to go to Start Interface and then launch PiICU. When you have this open, let's go up to Interface, New Windows Interface Instance from that file. Alright, so when you install Pi interface, you're given a template file that PiICU can use to create new batch files with some default parameters. To find that template file, let's double click OPC-int, and then within that folder, the template file that we want is this guy, OPC-int.bat_new. click that once and then press open. Alright, so let's first select a collective, the PyServe1, and then for the collective member, let's go down and choose PyServe2. It's best practice to have failover members point to different PyCollective members, especially when you're dealing with a certain type of PyPoints called output points. Alright, so once you have this selected, let's press OK. And then now we have a new interface instance with some default entries here. As it turns out, on this screen at least, a lot of the defaults exactly match the interface's settings over on PyInt1. So we don't need to change any settings here. For example, the point source is already set, as well as the interface ID. So over on the OPC int tab, let's input the OPC server node name first. And it was localhost on PyInt1, but from this machine, we have to point to that computer explicitly, PyInt1, and then the OPC server name, I have it saved. I'm just going to copy and paste it over here. Okay. Now, over on the next service section, let's input the display name, and I also have that saved. Down here, log on as, we have a username or a service account, so I'll put there as well. And then the password is student, all lowercase. All right. Now, the reason why we have this Pi interface run as a specific user has to do with DCOM. DCOM is a Microsoft technology that allows clients and servers to communicate. In our scenario, the client is this Pi interface, and the server is the OPC server. These two were built to follow the DCOM protocol. The majority of DCOM configuration has already been set up on these machines, but the last remaining step was to run the interface as this service account. This helps the OPC server recognize and authenticate this OPC client. For additional information and instructions, please refer to OSIsoft's DCOM configuration guide. Alright, so at this point, we can create the service for the interface through this button here, create. Alright, so the service account has been granted log on as a service, right? Good. Alright, so now it's officially a service. Now remember on PyInt1, there was another entry down here in this dependency box. Right about there. And it was for PyBuffSS, or PyBuffer subsystem. This hasn't yet been enabled or started on this machine, so let's go ahead and do that now. Up top, go up to Tools, and then Buffering. This will launch the wizard for configuring buffer. Right, so yes, we want to configure now. Right, so let's continue with configuration. See here that it detects one instance of the Pi interface for OPCDA. Right, so we'll click that checkbox and then press next. Next, we're presented with the option to run this as a specific user. So over here, instead of local system account, let's click change, and then use a Windows account. We talked earlier about an account to run buffer, so we'll find that now. It was PyBuffSS, and then the service account. Check names. Okay, there it is. The password, again, it's the same. It's student, all lowercase. All right, so let's press next. All right, so this change in service account isn't fully applied until the very end. So despite the error shown here, we'll get a final confirmation whether it does or doesn't work at the very end of this wizard. Let's click next here. And yes, this is fine. All right, so we choose where we want to store the files that buffering handles. And although we have this D drive, we're not going to deal with that in this class. So we'll stick it in its default C drive location. All right, so now it'll go through the process of starting the buffer as well as connecting it to the Pi collective. Great, it started, it's operational, and it can connect to the Pi serve 1 Pi collective. We're finished here, we can press exit. And what appears next is the actual buffering manager, where you can see a lot of statistics on how buffering is running, as well as what servers it's buffering to. In our case, we just have this one collective here. Okay. So back in PyICU, the very last step here, remember, we still need to get PyBuffSS to appear in this list. And just to explain this a little bit, the logic behind why we need this is just the way that Pi interfaces and the PyBuffer subsystem were written and designed. To properly link their data flow relationship, PyBuffSS must already be started prior to the Pi interface starting. And that's where these service dependencies come into play. Right? So to set that up, PyICU does most of the work for us. We can click away from this service tab here. All right, yeah, it has to save changes. Yep, that's fine. And then when we go back into service, it tells us about this dependency, and we have the PyBuffer subsystem now enabled, as well as an interface that's configured, and whether we want there to be that dependency, and yes, we do. So now it adds in the PyBuffSS for us. All right, so we're finished here. Let's just click Save at the top. All right. At this point, we've finished installing and configuring this Pi interface. We can try testing this single instance now. But before that, we have to keep in mind that there's an identical instance running on Pi 1. And until we get these two configured for interface failover, we can't have them both be running and servicing the same Pi points. So quickly, let's jump to Pi 1 and turn off its interface instance. All right, here in Pi 1, I have PyICU open, as well as this single instance selected. And then up top, there is this stop button. So I'll press that once. And of course, as this interface is stopped and the one on Pi 2 hasn't been started yet, there is some data loss that we're experiencing, but just assuming that we're in this kind of maintenance period, some data loss is to be expected. So now this interface has stopped. Let's jump back to Pi 2. All right, so we're back in Pi 2. I'm going to click this icon first. It's to view Pi message logs continuously. Let's have more space here. Now, this is pretty useful, these message logs. While the interface is starting, you can see a lot of what's happening as it starts up. Okay, so up here, now we have, let's start this interface service. And I'm just looking out for any potential errors in these logs, because they can be pretty quick. But a lot of the messages here are just purely informational. All right, so I don't see any type of errors or any issues that are popping up. So it's good now. All right, let's go to PyServe1 so that we can actually see some values for the PyPoints. Here in PyServe1, I still have PySMT open. Let's go to Data and then Current Values. And up top, make sure that PyServe1 is selected. I'm going to go up here to Tag Search. And to search for our OPC tags, we can just search using the point source of OPC. And I'll click Search. Alright, and I'm going to select several by holding down my Shift key. So I'll hold down Shift and select about this grouping of tags, and I'll press OK. Up top here is a Start Updating icon where you can see values update in real time. So that looks good. Looks like the PyPoints on PyServe1 are updating. All right, so let's go over to PyServe2. I'm going to uncheck and then select PyServe2. Let's go back up to Tag Search, and then OPC is how we're searching for, that's point source. Press Search. And again, I'll select a grouping of tags. Press OK. Let's watch them update in real time. Alright, good. So now we can see that the tags are updating on PyServe2. And this exercise of looking at both PyServe1 and PyServe2, both sets of tags, it shows us that end-way buffering from PyInt2 is working well. At this point, we have two identical interface instances that can connect to the data source and send data to the PyPoints on both PyCollective members. So they're ready to form a failover pair. In the next video, we'll review interface failover and then go through all the steps to configure it.